Hello everyone, welcome back to the Science for Kids channel. This is Furman, and today I'm going to explain to you a phenomenon called chemiluminescence. Let's find out what it actually is. Chemiluminescence is the emission of light caused by a chemical reaction. During a reaction, an electron of a reactant will transit from its ground state to an excited electronic state, and vice versa for when it releases energy in the form of visible light. Of course, not all substances would emit light during a reaction. Scientists have assigned a unique name to all substances that have this property. They're called chemiluminescent reagents. Luminol is one of the most common Luminol is one of the most common chemiluminescent reagents that we may have heard of in our daily lives. There are multiple uses for luminol, the most prominent of which being in forensic sciences, where it can detect trace amounts of blood in places like crime scenes. In today's experiment, we're going to recreate the chemiluminescence in our laboratory by using various chemicals. These will be sodium carbonate, sodium bicarbonate, ammonium carbonate, copper sulfate, and hydrogen peroxide, as well as one other chemical that I'm sure I've made you well aware of by now. We'll start with making 1 liter of solution A. That's why we need a 2000 milliliter conical flask, a stirrer plate, and a magnetic stir bar. Put the stir bar into the conical flask and place it on top of the stirrer plate. Then, measure and add 250 milliliters of distilled water and start the stirrer. Firstly, measure and add 4 grams of sodium carbonate into the solution, followed by 24 grams of sodium bicarbonate. And then, we need 0.42 grams of ammonium carbonate and 0.4 grams of copper sulfate. And finally, add 0.2 grams of luminol and add 750 milliliters of distilled water. Keep the stirrer plate working until all solids are dissolved. Meanwhile, we can start preparing solution B and make around 500 milliliters of it. Firstly, measure and add 25 milliliters of the 3% hydrogen peroxide solution into the cup by using a measuring cylinder. Secondly, top up the solution to 500 milliliters of distilled water and solution B is done. After solution A and B are done, we can start our experiment. In an empty beaker, measure and add 50 milliliters of solution A with the help of a measuring cylinder. After that, measure 10 milliliters of solution B to a new beaker. Done! It's time for us to switch off the light, get our camera ready, and mix! Wow, can you see that? The solution starts glowing. Do you know why? This is because during the reaction, an electron inside luminol has been made excited because of the reaction. And then that electron is transited back into its ground state and emits blue visible light. Well, it's just blue. What's the big deal? It's boring. Well, if you want to make this experiment more interesting, you'll need these highlighters. In most of the highlighters, there's a dye called fluorescein. Fluorescein is an organic compound which can absorb light waves and re-emit them. If the fluorescein has been added to our previous experiment, the color of the light emitted from the reaction will be different. This is because the fluorescent will absorb the light waves released by luminol during the reactions and re-emit them of a different color. I will now demonstrate how yellow, orange, pink, green, and purple highlighters affect the color of the light of the solution. Don't forget to like, subscribe, and comment on what you'd like to see next, and I'll see you in the next one. Peace.